Europa is widely considered the most likely place in our solar system beyond Earth to have life right now.
It's a moon, an icy world orbiting Jupiter.
Beneath its icy surface, a global ocean of water. Everywhere on Earth that there's water, there's life. So we want to understand, could Europa be a place where life might exist today?
3, 2, 1, lift off.
Europa Clipper is the first mission dedicated to exploring Europa.
This is the largest interplanetary spacecraft NASA has ever built and launched.
We have the right team, the right technologies to leverage to go to Europa now and unlock those mysteries that are just waiting for us.
The pictures we're going to get from Europa Clipper are going to blow our minds.
How could you not be excited about something as monumental as this?
You're looking live at NASA's Kennedy Space Center's Launch Pad 39A. SpaceX will soon begin fueling that Falcon Heavy rocket for NASA's Europa Clipper mission, a nearly 2 billion mile, 5.5-year journey to Jupiter's icy ocean moon. International Space Station showing just how massive it was before slamming into Florida's west coast as a Category 3 hurricane. And now this radar from the National Weather Service pulls data from NASA-launched environmental satellites. You see those red and green boxes just popping up everywhere. Those were all tornado and flood warnings before the eye passed directly over us at Kennedy Space Center. We were thankfully spared from the worst damage, just some broken doors and awnings, overturned vehicles and trailers, and some beach erosion.
Our challenge was the big one. We just saw the video, the center of Hurricane Milton passing right within 7 miles of this launch pad, 7 nautical miles, a Cat 1 hurricane with max sustained winds of 120 miles per hour, causing some minor damage to the pad, but looks like they fared okay.
Yeah, fared okay. SpaceX did an excellent job of assessing everything and making those minor repairs over the 24 hours and got the launch pad and the vehicle ready for launch.
And now let's listen in to NASA launch manager Tim Dunn, who will poll his team on readiness to load this rocket with propellant.
The most exciting thing about Europa can be summarized in one word: water. Now think about all the water on Earth and double that. That's what we think is on Europa.
But we need to go there to explore it, to understand, is this place a habitable environment that could potentially support life?
The propellant load and launch go-no-go poll is complete.
Scientists think Europa has the key ingredients to support life as we know it. Number 1, water. Number 2, energy. And 3, essential chemical building blocks. For the first time ever, we're sending a spacecraft completely dedicated to studying this moon.
The 3 main things that we're going to explore at Europa are the ice and the ocean and understand that intersection between the two, study the chemical composition of the moon, as well as the geology and whether it's active currently.
Europa Clipper is not specifically a life search mission. We're going to understand the potential habitability of Europa.
Jupiter's radiation environment is intense, and Europa sits in the worst part of that environment.
Jupiter acts like a giant particle accelerator. There are charged particles trapped in Jupiter's magnetosphere that rotate with it. And these particles slam against Europa and will slam into our spacecraft as well.
We protect the spacecraft in 2 ways. Number 1, we try to minimize the amount of time we spend in there, which is why we are orbiting Jupiter and just flying by Europa. The second way we protect against the radiation is by having an electronics vault that we put our computer and some of the other sensitive electronics inside, which is made of about 1/3 of an inch of aluminum.
With each flyby of Europa, the outside surface of the spacecraft sees the equivalent of 1 million chest X-rays, just as we're flying by.
It's a pretty long trip to get to Jupiter from Earth, but not that bad from a planetary standpoint.
From launch to the time we get to Jupiter is about 5.5 years. And along the way, we have a flyby of Mars and then another flyby of Earth to get gravity assists to slingshot the spacecraft out to Jupiter.
I hope for the future explorers who are watching this at home that they take away from this that humanity, when we come together, can achieve really cool things.
We are in a golden age of robotic spaceflight exploration. How could you not be excited about something as monumental as this?
I am most excited about the potential to unlock the secrets of Europa, the potential to really understand this crazy world that exists and has likely existed in this condition for 4 billion years.
Indeed. The only constraint that we did have was high clouds, and even that has been removed, so it doesn't get...
Interior and space environment. And most of Europa Clipper's electronics are protected in a special vault. Jupiter has one of the most punishing radiation environments in our entire solar system. Now, the spacecraft was assembled at JPL in Pasadena, California. You can see it there. Shipping it here to Florida for launch. Now, that took a lot of coordination. First, some parts, like its high-gain antenna, were removed so it could fit in a shipping container. Then 2 semi-trucks drove the spacecraft, plus support equipment, about 70 miles to March Air Reserve Base. There it was loaded into a C-17 plane for its flight to Kennedy Space Center. And then once here, it was reassembled, as you can see there, and fueled in a clean room before it was encapsulated into the rocket's payload fairing. That fairing is at the top of the Falcon Heavy rocket you see live there, and it keeps the spacecraft safe through launch.
Yes.
That's really cool. And when the spacecraft arrives at its destination, take a look at this video. So that yellow dot in the center, that's Jupiter, and then the white circle is Europa's orbit. The pink line is the spacecraft's trajectory, and this is showing how Europa Clipper will observe Europa.
Absolutely. So yeah, you can see these the pink orbits kind of building up over time as we orbit Jupiter and do successive flybys of Europa. We have this mission designed because of the really intense radiation environment. We don't want to bathe in that radiation all the time. So that's why we kind of do a quick flyby and then get out to be able to downlink all of our science data and do other engineering activities when we're outside of that radiation environment.
Yeah, I want to point out again how much science and skill goes into designing a trajectory like this so that we protect the spacecraft when it gets there.
Absolutely, and it doesn't happen by accident. We have to continually fire our thrusters to be able to maintain this trajectory.
For cracking and active geology, so we think it's either active now or was active in the recent past.
Once we get past this surface, we see this layer of ice. Can you tell me more about this ice and how much of the moon it covers?
Well, it covers the entire body, and the ocean is global. The crust it's about 15 miles or so, perhaps more or less, but it definitely blocks any sunlight from this water.
And only slightly larger than our moon. It's really, really cold at Europa. Surface temperatures range from about minus 210 to minus 300.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Ignition. And liftoff. Liftoff of Falcon Heavy with Europa Clipper, unveiling the mysteries of an enormous ocean lurking beneath the icy crust of Jupiter's moon, Europa.
Engine chamber pressures are nominal.
See that the chamber pressures are nominal as we hear. All 27 Merlin engines look great.
Rocket beginning to roll. Putting down 5.1 million pounds of thrust. Coming up, they're going to back off those engines just a bit.
So we're getting ready to head into max
Power
Q.
and telemetry nominal.
We hear that power and telemetry on the vehicle are good there. Everything's looking really
Falcon
well.
Heavy is supersonic.
They have reduced power in the center core to get through max Q, maximum dynamic pressure on the launch vehicle as we approach that. The 2 side boosters at full throttle.
A beautiful shot there as our camera team.
Max Q.
Locking into the rocket on a clear blue sky. The view from the booster camp back down on Earth.
And there we heard the call for max Q. The vehicle is passing through maximum dynamic pressure. Next thing up in about 2 minutes will be booster engine cutoff, where we see the 2 side booster engines, all 18, shut down and get ready for booster separation. But the vehicle is performing very well. Looking at all the telemetry that we have, power and trajectory are nominal.
We've been flying for just under 2 minutes so far. Everything looking good. These side boosters, once they do their job, they will be expended. If you're familiar with the Falcon Heavy, you know that they bring the boosters back on certain launches, but not on this one, because all of the performance is needed to push Europa Clipper into its proper orbit.
Things continue to look good as the vehicle heads down its ascent phase here. All telemetry is looking very nominal for this flight this morning. Falcon Heavy is performing very well.
Now we're just about 30 seconds away from separating those side boosters. Their engines will cut off first, then they will separate.
MVAC is chilling.
Starting to chill down that MVAC-D engine in the second stage.
And that's where we need to get the engine chilled to the proper temperatures before flowing liquid oxygen and RP1 into it. So they're conditioning the engine to make sure things are ready for when it's ready to start up.
Stand by for booster separation.
Booster engine cutoff. Side booster separation confirmed.
And there they go.
Those two boosters previously flown on Psyche. This will be their 6th flight. We thank you for their service this morning. They did a great job of getting Falcon Heavy and Europa Clipper on its way as the center core takes over and continues mission down its ascent. Things are looking really good in the telemetry. Power and trajectory look nominal, and chamber pressures on the 9 center core engines look really good.
In just a little more 20 seconds from now, we'll get the cutoff of the main engine on the center core booster that remains. 4 seconds after that, we will separate. Flying out over the Atlantic Ocean. There's a look from inside.
There we see stage 1
stage
shutdown
separation confirmed.
and stage separation from the center core. Getting ready for MVAC startup, SES-1.
We're getting some applause here in the Mission Directors Center, and there you see the MVAC-D engine lighting up.
Next thing up in about 10 seconds will be fairing separation.
NYPY FTS has saved.
And the fairing has protected Europa Clipper on its ascent up into space, but once we get into space, we don't need that fairing anymore.
Fairing separation confirmed.
Fairing has separated, and those will be recovered, Daryl, by SpaceX's own recovery ship, Go Cosmos.
And there you see them falling away into space. That is the only part of this rocket that will be recovered.
The glow of the MVAC-D engine as it performs its first burn here. This is about a 3-minute and 47-second burn. Things are looking great. Matter of fact, this is one of the shortest first burns that has been done on a Falcon Heavy by SpaceX, but it is required to get us into that parking orbit for that long coast that we have to get ready for the interplanetary trajectory that we're going to need to get Europa Clipper on its way that we heard Jenny talk about to get those Earth assist slingshots as it heads on its way for its mission. So things looking really good this morning with the performance of the Falcon Heavy. MVAC is performing well, and everything looks good thus far in today's mission.
Usually those burns are the other way around, with a longer first burn and the shorter second burn, but in this case it is reversed. As we look at some crystal clear views of the MVAC-D engine, the stage 2 that's carrying Europa Clipper. Orbital light is shining both on the spacecraft, the second stage, and on planet Earth.
Center core FTS has saved.
There we've heard that the flight termination system on the center core has been saved as it heads back to splash down. Things are looking good. I can tell you, Darryl, we had a beautiful weather day for launch, and as we're looking at MVAC flying in space with Europa Clipper, it is such a gorgeous view with Earth behind it, and so we could not have had a better day for a mission launch today.
No doubt about it, Mick. It was simply gorgeous. We had a hurricane a week ago, but after that pushed out, it brought us in its wake near perfect weather for launch. And now we're into space, dealing with the harsh conditions up there.
Stage 2 FTS is safed.
Stage 2 has made its way into space, far enough away for us to be able to safe the flight termination system from a safety perspective. We're about a minute away from second stage engine cutoff, as we'll see the MVAC-D shut down and get ready for a long coast, getting Europa Clipper into that parking orbit and on its way for the next firing that we will have, the second stage, number 2, to get it into that interplanetary transfer orbit that we need to get Europa Clipper started. So things looking very well this morning. We're about 30 seconds from that stage engine cutoff, which we refer to as SECO 1.
That's right. We'll get into that. Guidance. Get into that coast phase. These views brought to you, of course, by ground stations across the track that are pulling in the high-resolution data from the cameras. Burn looking good, just a few seconds away from cutting off from that first burn. And there it goes. The first burn is complete.
Yep, things look really well on the stage burn result. Apogee paired.
The ingredients for life outside our planet. It will take the spacecraft 5.5 years to travel the nearly 2 billion miles to Europa. This is a mission developed by NASA's Jet Propulsion Laboratory in California and Johns Hopkins University's Applied Physics Laboratory in Maryland.
Europa's surface. I think it's one of the most complex surfaces in our solar system. Typically, when you look at another planetary surface, it's covered with craters, just like our moon.
There are shockingly few impact craters. So that means something is going on to erase the craters, just like happens here on Earth, and on Earth we call that geology. One of the key questions right now that we have about Europa is whether or not there's plume activity.
Plumes are one way that you can definitely get ocean material to the surface. We really need a spacecraft in the system that's watching Europa to see when those plumes are happening, if they're happening. Europa Clipper is orbiting Jupiter, and it's performing 49 flybys of Europa.
Each time we make a flyby, we turn on all of the instruments at once.
Most of us know about cameras because that's what our eyes see, but there is a whole slew of other instruments on board Europa Clipper that expands our vision.
We have 4 different instruments that we're really using to take images of Europa's surface. We have the visible wavelength, the near-infrared, the far-infrared, and the UV, the ultraviolet.
We're hoping to see evidence of change, new cracks, new surface colors that indicate different materials, maybe have moved around or come up from the subsurface.
We have an instrument that can sniff the very thin atmosphere, the gases, and determine the composition with extreme precision. And we have another instrument that can tell us the composition of dust particles.
We have a magnetometer and a plasma instrument that are going to be studying that magnetosphere environment that Europa is sitting in and Jupiter's magnetosphere environment.
The magnetic field of Europa, in turn, can tell us about the properties of the ocean. How thick is it, and how salty is it?
And then we have this novel ice-penetrating radar that will try to get below the ice shell.
Last but not least, we have a gravity experiment using the communication system of the spacecraft, and from that we can get essentially a map of the gravity field.
We can get the shape, understand what's underneath, maybe even get some information on the depth of the ocean. It's really a sophisticated payload.
The pictures that we are going to get back are going to be just fantastic.
The legacy of Europa Clipper will be just a treasure trove of knowledge about this world.
Just to find an environment that is similar to the one from which life arose on Earth would really be groundbreaking. It would be awesome.
We don't know if Earth is the only place that life got started, or if it's really common. And a really important way to get at that is to understand, is there life elsewhere in our solar system?
Gather all the hundreds of different components that make up Europa Clipper.
My name is Andres Rivera.
My name is Jenny Kampmeyer.
My name is Sarah Elizabeth McCandless, and I am an interplanetary navigator.
I'm Deepak Srinivasan, and I work to make sure that we can communicate with the Europa Clipper spacecraft.
And making sure that Europa Clipper makes its way to Jupiter safely.
I work on Europa Clipper, helping science fiction become science reality.
We're going to Europa to determine whether we have favorable conditions for life.
Here on Earth, no matter what environment you're in, wherever there's water, we've found life.
We're going to investigate all those ingredients that we think have led to life as a whole.
But to actually do that, a lot of engineering has to happen.
There's no one person that is responsible for getting this spacecraft built, for designing our science campaigns.
I'm helping enable solar system exploration, helping to enable exploration of the universe.
We're doing some really humanity-changing science.
It's a hard journey to get here. It felt like an impossible dream.
For me personally, being an immigrant, I never really imagined that I would have the opportunity to participate in something like this. Just seeing it up here and knowing that it's going to be up in space, it's pretty humbling.
Seeing it from its infancy to actual realized hardware, to get that on its journey to Europa, it's just going to be a wonderful feeling.
It's been very motivating to see that a part of me will go to Jupiter.
I'm contributing this tiny part of something that's going to help us understand better about our universe.
We're going to be exploring literally the frontiers of life.
Who knows what mission today is going to be that inspiration for the next generation.
That's such an honor to be a part of.
We use that number to estimate the number of microbes living on the spacecraft. Think of Europa's ocean like a nature reserve. We don't want to contaminate it with anything from Earth.
Out of the thousands of samples that we've collected, only about a dozen have required us to ask the engineers to re-clean the hardware so that we could go in and resample it.
Absolutely wild, right?
Yeah, take a look at the video now. This is them actually stenciling, like you said, those names on there. And I just love how many people, again, as you said, 2.6 million wanted to take a part in this and have their names go into space.
It really is incredible that, you know, the public got so excited. Everyone wanted to send their name along Europa Clipper out to Jupiter.
And just really quick, let's...
With a series of Galilean moon flybys to reduce the size of the orbit, the capture orbit, to one that's more in resonance with Europa's orbit. So about 11 months after orbit capture in April of 2030, we'll perform our first Europa flyby in March of 2031.
The cutoff, the second burn is complete. And we just caught some video of right there at the end of the second burn, and we've got some results there, everything looking good.
Yeah, TDRS network did its job. We just switched over to ground station, and we were able to pick up that
nominal
video.
orbit insertion.
And nominal orbital insertion has just been reported, and stage 2 looks good. So our next event, Daryl, will be spacecraft separation. Very excited for that, and I know everybody's looking forward to that with the successful launch today.
We are looking forward to seeing Europa Clipper go off into space off that second stage, but in the meantime, we'll send it back to Megan and Jenny.
Camera view of Europa Clipper on the front of the SpaceX Stage 2 launch vehicle.
Yeah, that's a great shot of the spacecraft going out the forward end. Pranay Mishra, he's with the mission support team.
Okay, all stations, we are waiting for a sign of initial acquisition. Again, Telecom will confirm when we have carrier lock, and DDM will let us know when they see the first packet down.
You can see the second stage and the spacecraft just hit orbital sunrise, fully illuminated by the sun coming over the Earth. And as you just heard the flight director say, they are now going to be monitoring for an acquisition of signal.
Yes, this will be the first time the spacecraft gets information. Looking forward for that.
The hope is that they would get it in the next few seconds. We're now looking at a split screen. On your left, you see Europa Clipper. On your right, this is telemetry coming. Or actually, this is the ground station looking for a spike, looking for a handshake with the spacecraft. And we expect to see that in the form of a blip.
Daryl, as you say, they expect that here in a few seconds, but it can happen in a few seconds or anywhere from 15 minutes from now. So the team is closely monitoring this and looking for that, and we're hoping that we can gain AOS here very shortly.
Yes, there's a broad range of times for which AOS is expected.
Flight GNC. Go. Just wanted to comment from the video that we could see that the sun was on the neg-Y side of the spacecraft. There were very low visible separation rates, and the negative Z-axis was pointed at Earth, so this should be favorable for comp.
Many questions raised by the mission that we still need to answer.
The story is never complete.